complex numbers, example 7. Before we do example 7, I'm just going to draw your attention to a new piece of terminology that we've got here. Something called the conjugate. Now, we talked about this earlier. Every complex number has a conjugate, which is like a little partner to it, if you like. And you find the complex conjugate by changing the sign on the imaginary part of the complex number. And we use this notation, Z with an asterisk. I do my Z's like this so they don't look like 2's. And a little asterisk in the air like that. That's the conjugate. So the complex conjugate of 4 plus 7i is 4 minus 7i. You change the sign on the imaginary part. So for 1 minus 3i, the conjugate would be 1 plus 3i. And then resist the temptation to change the sign on the real part. The conjugate of minus 4 minus 3i is minus 4 plus 3i. The sign on the real part doesn't change. And there's something very important about a number and its conjugate, and that's what we're going to look at in example 7. So when we multiply them together, 4 plus 7i and 4 minus 7i, you might be able to predict what's going to happen. And if I give you a little bit of a clue, 4 plus root 7, 4 minus root 7, a similar kind of thing happens. You may remember doing this in C1, a particular topic where you multiply 4 plus root 7, you would multiply it by 4 minus root 7, rationalising the denominator. Well, it's a similar kind of idea. So we've got 4 plus 7i and 4 minus 7i. And if we multiply those together, we're going to get 16 minus 28i plus 28i, and then at the end we're going to have minus 49i squared. Now you'll notice that the two middle terms cancel out because they're positive and negative of each other. So we're going to get 16, and then remember I squared is minus 1, so it's 16 plus 49, which works out to be 65. And the fact it's 65 isn't particularly important, but what is important is the fact that it's real and there's no imaginary part. So in the same way that you rationalise a denominator, you get rid of the surds. Well, similar kind of idea here, we get rid of the imaginary part by multiplying a number by its conjugate, and that's really important later on when we look at division of complex numbers.